3 months ago, Harvard published a study linking red meat consumption to diabetes, and news headlines exploded around the globe. And a couple days later, a dozen YouTube episodes and blog posts erupted on the scene. What caught their attention and mine was the strength of association.
Researchers also in the study found patients who ate the most red meat had a 62% risk of developing type 2 diabetes compared to those who ate less red meat.
Every news article I could find was positive about the study, and every YouTube episode and blog post I found was wildly negative.
Anybody that has a CGM could debunk that study in about 3 seconds.
If you want to show an example of how not to do scientific research, this is it.
I recognize some of the news authors and YouTubers. For example, I was aware of Guardian Health editor Andrew Gregory because he had won a Royal Statistical Society award last year for his reporting on British healthcare. And I'm very familiar with physician and YouTube star Ken Berry, who got over 400,000 views for his debunk of this study, and for previous studies on the same topic. The name I didn't recognize was Xiao Gu, the lead author of the Harvard study. What struck me about all the coverage is they all rushed to catch the news cycle. No one mentioned that in this study, fish had roughly the same peril as red meat. I didn't see that coming. Intuitively, you would think that would cast some doubt in the minds of some people about the validity of the study. No? More on that later. No one covering this study had much background in epidemiology, far as I could tell. But what stands out with this paper is it took advantage of some advances in epidemiology that didn't appear in previous Harvard papers. I have a decent background in epidemiology, but to me it looked like it would take some time to fully understand these new methods. I am the luckiest guy in nutrition because I'm a retired scientist and a one-man band who can just pack up his gear and go ask Harvard scientists all the questions I want. I don't have to worry about the time or cost, and I don't care about catching the news cycle to pump up views. Are you Xiao? Hey, glad to meet you.
Nice to meet you.
So you have 2 master's degrees. One's in epidemiology and one's in biostatistics. They'll seem like the same to me.
Not really the same. Well, actually, biostatistics is the tool for epidemiologists. Mm-hmm. They have different focus. So epidemiologists, we study the risk factors, the reason for the diseases, and we have theories about causal inference. And to analyze our data, we have to use biostatistic models. Biostatisticians, they develop those models, and they keep updating their models to add things that can adapt to different data. So we develop it together, and we work closely together.
The press did reach out to Dr. Gu and Dr. Willett, a co-author, with their questions, but they couldn't go deep because of the tight deadlines to make their press cycle, and anyway, they were limited in space. None of the YouTubers reached out to the Harvard scientists with questions. The New York Times actually conducted a phone interview with Dr. Gu, and 3 weeks later they reported on a rigorous German meta-analysis of 37 studies on red meat and diabetes. The New York Times reporter who covered that story was Alice Callahan, who has a PhD in nutrition and a respected book in its 2nd edition, The Science of Mom. That German meta-analysis broadly supported the conclusions of this Harvard study. I didn't see any coverage of it on YouTube or blogs. The major objection YouTubers and bloggers had about this study is that it's epidemiology.
Again, a correlational study is one that can only establish a coincidence.
On these food frequency questionnaires and asking people what they eat and how much they eat, I mean, that's fraught with lack of accuracy and precision.
This is the kind of stuff that makes nutritional epidemiology the literal laughing stock of all scientific research.
Sure, I'm Christine Hess. I'm the Research Center Manager here at the Framingham Heart Study. I'll show you this way.
Being the luckiest guy in nutrition, I got permission to tour the legendary Framingham Heart Study campus near Harvard on the 75th anniversary of the study. Here's their director, Dr. Daniel Levy.
At the end of the 20th century, the Washington Post published an article describing what they considered to be the 100 most important medical advances of the 20th century. At the very top of that list, not surprisingly, was the introduction of antibiotics. And number 4 out of the top 100 medical advances of the entire 20th century was the Framingham Heart Study.
In cardiology, it often makes it higher on the list. This paper was about cardiology's 10 greatest discoveries of the 20th century, and number 2 was Preventive Cardiology and the Framingham Study. They called it one of the most impressive medical works of the 20th century. Like Harvard studies, it is epidemiology, and it depends on food frequency questionnaires to unravel the role of diet. They famously coined the term risk factor in 1961, figured out that high blood pressure was not the robust indicator of health that once seemed so intuitive, that dietary factors have a profound influence on heart disease, and now they're able to understand the interplay of genetic factors and diet like no other study because they've followed the children and now the grandchildren of the original participants. And didn't your last original participant just die recently?
The last participant died about 4 months ago at age 105.
Wow.
And to think that she was a participant in the study for almost 75 years prior to her death, to devote so much of her life to a cause she believed in.
They've been able to observe how what seemed like the same food affected different generations differently. Here's what Dr. Levy wrote in his wonderful book. The American palate, getting ever more demanding, has grown used to highly marbled meat from plump animals that get virtually no exercise. It is juicy and tender, but it bears little resemblance to the meat our farming and pioneering ancestors ate. Dr. Levy joined the Framingham study right after finishing his postdoctoral research in cardiology in 1984. I asked him if analyzing Framingham data affected his own diet. What about beef?
I don't eat beef.
Why don't you eat beef?
I haven't eaten beef in over 40 years.
Why not?
A personal choice.
I wish a class in epidemiology was required in med school because it would help people understand that food frequency questionnaires are nothing like they imagine them to be.
How many muffins have you had in the last week? How many hot dogs have you had in the last week? Was it 1, 2, 6?
That's right. It's hard to remember that. I think Mike is referring to short-term dietary recall. That's usually administered as 24-hour recall so people can remember. Those surveys show some short-term variations, like for holidays.
Well, last week I traveled, or I was at a conference, or I had my kids and we all went to Disneyland, so it's hard to totally remember everything you ate.
What most people can remember is their habitual pattern of eating over the last year, which is more biologically relevant in studies of chronic disease like this one. Ask most people and they can tell you how often they have oatmeal for breakfast versus bacon and eggs. So some people dismiss your studies because they're based on questionnaires. Mm-hmm. And the language they typically use is, I can't even remember what I ate yesterday. And you're asking me to remember what I ate during the whole year? Mm-hmm. How does that work?
It's by intuition, it's a questionnaire, but actually the underlying mechanism is not that simple. It's just in the form of the questionnaire, but we design it carefully.
Can I stop you there? Carefully means what? Doesn't it take... Walter listed in his book that it can take 2 or 3 years to design these questionnaires.
Yes. There's a lot of effort on designing, on initially designing the questionnaire because, well, there are 3 major compartments on the questionnaire. The first one is the food list, what food we are going to ask people. Another one is the frequencies, and also the third one is the portion size. I think most of the efforts are on compiling a food list, and we want to be more comprehensive because we want our questionnaire to capture people's nutrient intakes more comprehensively. So the food list should be long, but another issue is that if you have like 200 questions or 300 questions, people may quit in the midway. So we have to have a reasonable number of items on our questionnaire, and we have to identify those most informative foods, and that actually based on some statistical analysis, and I think that was designed way before I was born, but so I learned that from the book. So they initially had a pilot study to recruit only a small group of people. And they sent them a long questionnaire, which is a more comprehensive one. And they collect that and analyze all the nutrients. And they identify the most important nutrients and use a statistical method called stepwise regression to select the foods that can explain the most of the variability in the nutrients, and one after one, then get a list, a smaller list. And after that, they also have to test that again and again. And more importantly, our food list is evolving all the time. We update our questionnaires every 2 to 4 years. And so if you look at our questionnaires, every time there will be 1 more or 2 more foods or maybe some less foods, because people's dietary behaviors are changing and those foods in the market, they are changing. So that's a lot of work.
And that brings up the importance of having responsible people filling out the questionnaires.
So you have these huge studies, Nurses 1, Nurses 2, healthcare professionals. They've been going on a long time. And epidemiology gets better with time, right? Because
yes.
You have more events. Sadly,
yes.
You have more deaths.
Yes, more deaths and also more cases.
Why health professionals? Why is the cohort made of health professionals?
I think originally the idea is about response rate. And also, at the very beginning, they expect to follow up people for decades. So we have to ask people to retain, to stay in our cohorts. And health professionals, they're more they're more likely to have strong commitments on those research. And it turned out that that's true, and our response rate is pretty high. And also, we keep asking people to provide like medical records or even samples, blood samples or tissue samples. And those health professionals, they have easier access to those things, and they are more professional to get things organized and send back to us.
It seems like they would be more able to understand the importance of this study because they are health professionals.
Yes.
How are they a little different than someone like you or I? You probably sit a lot at your computer, as I do.
Mm-hmm.
Aren't they on their feet a lot, nurses walking up and down the halls of the hospital? And
in terms of physical activity, I think that's not the major difference between them and us. And yes, I do sit a lot, but there are also a lot of other occupations they don't. I think the major difference is the educational background, and also occupation itself is a major difference. We also got criticisms about our external validity of our study, the generalizabilities. But for most of our results, because it's about the biology, so we have the biological basis, so it's reasonable to believe there's no difference between depend on the educational status or occupation.
You got some criticism for the external validity. What does that mean?
So when we find the association, and people may say that you conducted the analysis in a very special group of people, and how that can be generalized to the general population. For some research questions, that could be an issue, like those behavioral things. But for, like I said, like red meat and type 2 diabetes, which is supported by the biological mechanisms, that's not likely an issue.
The next thing that some people don't like about Harvard nutritional studies is the industry talking point that Walter Willett, the longtime head of the Harvard School of Public Health, is an ideological vegetarian. Nina Teicholz wrote on her blog, Harvard has been anti-meat for 30 plus years. Why? Red meat is bad for health. We hear this from virtually all our nutrition authorities, and so it must be true. Far less well known is the fact that this fear of eating red meat can mainly be traced back to a single person. Harvard's Walter C. Willett, the first and most prominent anti-meat champion in academia. It's a common strategy for industry to isolate a prominent scientist whose research findings don't align with industry's financial interests. But I think everyone can see this is made up. Most people know the story of Senator McGovern's original Dietary Guideline Committee in the 70s that tried to advise Americans to eat less meat based on the concerns of scientists. Walter hadn't even received his PhD by then. In this Time article from 1961, Ansel Keys said some damning things about meat, and he was in academia. I made a searchable PDF of that article and made it publicly available. Nina wrote, "What is certain is that for 30 years, Willett has been a fervent champion of a vegetarian diet. His advocacy is run through with ideological beliefs, some linked to an actual vegan-promoting church. And it's hard to imagine that these factors do not interfere with the pure pursuit of science."
There was a long essay written about Walter Willett when your paper came out. It was a response to your paper. And it was, Walter Willett is the reason for the concern about red meat. He's an ideological vegetarian, and he has been since 1990. So he gets everybody at Harvard to publish papers on the evils of red meat. Is that what you're doing? You're just publishing a paper on the evil of red meat because of Walter?
I think that's not true. Well, according to Walter, he said he's a flexitarian. He also eats red meat. He said he eats bacon, maybe like once a year.
Yeah, he told me yesterday he eats beef once a year. Doesn't he promote the Mediterranean diet?
Yes, he promoted my Mediterranean diet. But actually, we are not promoting vegetarian diet. It turned out that most of our findings find that plant-based foods are better, but we are not saying that you should never eat meat or any other protein, animal-based protein. And also for me, I'm not a vegetarian. I also eat meat. So people may blame that Walter Willett is biased, but I am not biased.
Yeah.
Zoe Harcombe's blog was even more of a shock to me than Nina's. It led with the line, "This makes no sense from the outset, as diabetes is a glucose handling issue and meat contains no glucose." That's a very intuitive idea, and probably most consumers believe that. But data has a way of disproving our intuition. I think the most reliable insight about diabetes comes from actual diabetes researchers who collect solid data. Roy Taylor may be the most respected diabetes researcher in the world because his team has transformed our understanding of diabetes by performing MRI scans of the pancreas, liver, and muscles.
First of all, glucose is a very useful index. It just as a general index of how the diabetes is progressing. But when we look under the surface in type 2 diabetes, it's the fat that's driving the problem with glucose. So, yes, using glucose as a measure of what's happening is fine, but it has become a sort of mesmeric substance that's diverted scientists away from what's really happening.
For example, they discovered that the pancreas gets ragged with diabetes and loses its ability to function. If it hasn't gone too far and we're successful in changing our lifestyles, it can make a comeback in a couple of years.
This is what we found. There is a really wasted, raggy pancreas.
That's somebody with type 2 diabetes?
With type 2 diabetes.
That could have been me.
That could have been you. Here's your pancreas, Michael. 5 months later, it hasn't much changed. It's certainly not increased very much. But after a year, it's decidedly increased. After 2 years, it's well on the way back to normal. And so we think this is a restoration of insulin action in the pancreas.
They showed through convincing MRI images that the body begins to store fat where it's not supposed to be stored, in the liver, pancreas, and muscles. What is sometimes tragic is consumers believe that if you eat no foods that raise blood sugar, you've fixed the problems under the hood. Even some doctors believe that.
In fact, I will ask people when they come in, what is diabetes? And they'll say, well, it's the pancreas. No. The doctors aren't measuring the pancreas when they diagnose you with diabetes. They're measuring the blood sugar.
But as Virta Health data showed, suppressing the symptom, high blood sugar after a meal, may not be the same as fixing the problems under the hood. Virta put patients on a keto diet plus metformin, and patients showed good improvement in their blood glucose the first year. But their data showed blood sugar drifted up in the second year for most people in their cohort, indicating diabetes was progressing. Dr. Taylor promotes a Mediterranean diet low in saturated fat and moderating starchy vegetables like white potatoes. That ties with this Harvard study because the Mediterranean diet, as defined by nutritionists, is low in red meat and saturated fat. Zoe's blog is long with many claims, but it was referenced by so many YouTubers I'll quickly cover 2 more claims and get back to the Harvard study. The first is she featured this quote, "For a modern disease to be related to an old-fashioned food is one of the most ludicrous things I have ever heard in my life." That is intuitive. The problem is, with the advent of modern breeding, red meat is a newfangled food. McDonald's patties are now 64% fat by calories. This 80% lean ground beef is 20% fat by weight, but 71% fat by calories. That's because fat has 9 calories per gram, where protein and carbs have 4. For example, bison has 1/4 the calories from fat for similar cuts of meat, just the way beef used to be before modern breeding techniques. Zoe ended her blog with an anecdote. Many of the YouTube episodes were filled with anecdotes, and I think they are the best way to collectively lose our minds. Every diet tribe is filled with positive anecdotes, and sometimes I think every anecdote has an equal and opposite anecdote. For example, Zoe's anecdote was about Sean Baker, a big, strong 57-year-old with a book who lifts weights and eats a lot of meat. A few years ago, a very popular anecdote was about Charles Poliquin, a big, strong 57-year-old with books who lifted weights and ate a lot of meat.
And it's been shown since 1982 at Tufts University that the best 2 predictors of how long you're going to live were actually muscle mass was number 1, number 2 was maximal strength. It has to run into a field, swim, or fly. If it doesn't do that, it's not a protein.
When Charles died at 57 from his heart attack, his name instantly disappeared as an anecdote, except in opposing diatribes. The same exact thing happens in keto and vegan diet tribes, and when they're confronted about their former anecdotes, they say, well, it must have been genetic. And that's how, if we hang out in just one diet tribe, we come to believe everyone in that tribe is healthy, and people in other diet tribes are struggling with their health. If you expose yourself to a lot of diet tribes, as I do, you see a constant flow of people from one diet tribe to the other and then being canceled by their former diet tribe. And that is why scientists who actually collect data focused on, say, nurses instead of diet tribes have the more accurate picture.
Dr. Willett, Walter Willett and D.V. Tobias, they have a course called Nutritional Epi, and that's the core course for our PhD program. And I helped TA that course for the past 2 years. And I also TA'd another advanced nutritional epi course.
It's based on that book that Walter wrote?
Yes, mainly based on the book. Yeah.
So I read that book, 512 pages, loved it. I thought it was great. But I poked Walter yesterday and said, when are you going to update it? And he said, oh, I have so much to do. I want to update it, but I'm very busy.
That's also my question to him.
You asked that question.
I think he should also update that.
What would you say, what needs updating the most in that book?
Well, he listed a lot of evidence, but I mean, in his book as examples. But over the years, there are a lot of updates on evidence, so mostly on those. But the scientific methods, the nutritional epidemiology method, that's pretty solid. But we also have updated methods as well, like those on regression calibration or measurement error correction. Like over the years, everything's developing.
Near the beginning of the paper, you said the effect of markers of glycemic control and inflammation have not been seen in short-term trials regarding red meat. But in longer-term trials, it does show up. Why is that?
Well, what I want to imply is that long-term trial doesn't really exist. Well, especially in nutritional epi. So I think I cited a meta-analysis about those red meat trials, and we found that the median follow-up period is only 8 weeks. Yeah, but so for type 2 diabetes, it takes decades to develop. So within 8 weeks, you can never use type 2 diabetes as an outcome. Instead, they use those biomarkers. But
your cell phone presents a text from your daughter.
Sorry about that.
You're not responsible for the content of the text.
I have to put my phone on Do Not Disturb. I forgot to do that.
I read those papers that Xiao referenced. They got picked up by YouTubers.
Eating red meat does not cause type 2 diabetes, and now results from a large meta-analysis back this up.
That paper was funded by Beef Checkoff. Marion Nessel has me so I can tell from reading a few sentences in the abstract who funded studies like this and why they did it. Marion explained that Beef Checkoff is sponsored by the USDA. and it taxes beef producers and uses the funds to promote beef sales. The 3 authors of this paper work at a small consulting firm. There is a desperate need for consumers and doctors to understand how to spot studies like this because they're so effective for beef checkoff and masterpieces of sleight of hand. 1, they don't cost much because all you need is a computer and internet connection, no participants. Anyone can do a meta-analysis. 2, the beef checkoff knows that a collection of randomized trials like this sounds like the gold standard to consumers, and it can be for drugs. 3, but they've known for decades that short-term randomized trials don't work for things like smoking and diabetes that take decades to develop. Few consumers know that. 4, they know not to mention words like cholesterol and TMAO, which could scare consumers, so this paper didn't mention them. But here's the thing, I actually read the papers included in this meta-analysis. Who does that? For example, this one was 10 weeks, the longest one they included. As you can see, it doesn't have to do with red meat and diabetes, but general protein and TMAO, a word they never mentioned in Beef Checkoff's meta-analysis. TMAO is considered a risk factor for heart disease. This 10-week study only mentioned the word diabetes in passing in this sentence. High-protein diets are also associated with an increased prevalence of diabetes and impaired kidney function. Protein for the study came from a wide variety of plants, fish, poultry, red meat, dairy, and eggs. And the conclusion was TMAO increased on average in the participants 5-fold when protein went from 0.8 grams per kilogram of body weight to 1.6. None of this information was included in the meta-analysis paper. Why the study was included in a meta-analysis of red meat and diabetes, I will never know. Maybe because it was 10 weeks in duration, and that sounded impressive. The Beef Checkoff paper did bury an interesting line at the end. Individuals with metabolic dysfunction and pre-existing risk factors for type 2 diabetes may respond differently to red meat intake, as evidenced by an increase in fasting glucose in the subset with metabolic dysfunction, and this deserves further investigation. These Harvard studies are funded by the NIH, by the way, although there are conspiracy theories about Walter on the internet.
You said one of the reasons for doing this paper was you now had 9,000 more cases than in the previous papers because time had gone on, and also you had methodological advances. I have trouble with that word. What were those methodological advances?
In this paper, we have measurement error correction because people blame that our dietary questionnaires, the food frequency questionnaires, are not reliable. So we respond to that by correcting measurement errors statistically. And this is one advancement. Another thing is that we study the latency period with our repeated measured dietary intake. Most of the other studies, they couldn't do that because they don't have those repeated measures.
In other words, they have the baseline measure, but they don't repeat the measures. So what do you mean by latency? How long the disease takes to manifest?
Yes, well, it's the period between you exposed to the risk factor and the disease diagnosis or the incidence of disease.
I see. Which is typically a dose response.
Kind of related to dose response, but more of the underlying mechanisms happening in your body that you never noticed until you were diagnosed.
Yeah, you go to the doctor and they say,
yes,
you got type 2 diabetes. And you say, how'd I get that?
So is that might related to your diet over the time or maybe even 20 years before you are diagnosed?
You did some weighted calibrations and it changed the results quite a bit. What were those weighted calibrations?
It's actually called regression calibration, but we calibrate our FFQ against a more...
FFQ is food frequency questionnaire.
Food frequency questionnaire. Yeah. And well, in nutritional epi, there are 3 major dietary assessment tools. FFQ is one, and another one is called dietary records, which ask people to write down what they eat and also weigh what they eat.
Oh, I see.
Yeah, that's well. A lot of people think that's more reliable.
I see.
And so there's no perfect measurement, but dietary record, if we measure it repeatedly, then that's more reliable, and people view it as a gold standard. Yeah. So if we calibrated our FFQ against a more reliable measurement, then we can correct the measurement errors in FFQ.
When you made that correction, it looked like it was very substantial, almost 50% difference.
Yes.
And can you explain why that is?
That could be due to a lot of reasons. Not necessarily the change in the main intake, not necessarily underreport or overreport, but it's we corrected those within person variations. We also corrected not between person, those systematic errors and random errors in our FFQ measures. Yeah, I will say that the original risk ratios, the original association, it might be underestimated due to error, due to either random error or systematic error. But after the measurement error correction, we are reflecting an association closer to the truth.
So a doctor friend of mine messaged me yesterday in commenting on this paper, and he said he wanted me to ask you that question because he said there's an impression that nutritional epidemiology overestimates the effect, but in his experience, it underestimates it because people underestimate how much food they report that they ate.
It's not specifically about underestimation or overestimation. So in epidemiology, we care more to estimate the association. We care more about the rank among people.
I see.
The rank of dietary intake, and that can make the difference in the association.
I see.
One source of error is called random error. So before the calibration, people may misreport. Some people may underreport, and others may overreport. So the distribution is wider, it's flattened. But after the calibration, after we remove those random errors, the distribution is actually narrowed. And with a narrowed distribution, we can distinguish people with disease, with higher risk of disease, and people with lower risk of disease more clearly. That's why our association became stronger.
So you said that the people who ate the most red meat were also more likely to smoke, to be overweight. What, did you say do less exercise?
Yes, but that's our, I think that's from our table 1, which shows the baseline characteristics of our population. I wouldn't say that table can show anything causal, but it just indicates which factors could be confounders and help us identify what we should include in our model to control those confounders.
BMI and whether they've been diagnosed with type 2 diabetes seem critical to this particular study.
Yes, BMI is important to this study.
Because it's a risk factor, a major risk factor for type 2 diabetes.
It's a risk factor, yes. And in our study, we view it as a mediator, or more of a mediator between red meat and type 2 diabetes. So by saying mediator, it's so people eat more red meat, then they have higher BMI, then they have diabetes. So, but also people feel that BMI is a confounder. So because you have higher BMI, then you change your dietary behavior, you change your red meat intake, and also BMI is associated with type 2 diabetes, that's for sure.
I had trouble with one sentence. You said BMI was not adjusted in the primary analysis, considering its potential mediating role in the associations between red meat intakes and type 2 diabetes. What did you mean?
So in epidemiology, if it's a mediator, on the pathway between red meat and type 2 diabetes, we usually don't adjust that. If we adjust that, we call it over-adjustment. So you are actually blocking one of the mechanisms for the total effect of red meat. So, but a lot of people also said BMI is a confounder, as I said before. So we also, in our sensitivity analysis, we did adjusted that. But even after adjusting for BMI, our association is still strong.
But BMI was a big factor, just couldn't explain all of it, right?
No, it couldn't explain all.
Half of it?
Yeah, we have a mediation analysis that can calculate how much of the effect is accounted for by BMI. It's about a half. But for those epidemiologists, they study causal inference. They have more fancy methods to investigate on the mediating role. But for our simple analysis, it's about half of the effect.
So you just used the term causal inference. Your critics, the beef industry, your friends in the beef industry, as Walter refers to them, they constantly say epidemiology only measures association. It doesn't give you any clue on cause. But I say, as an earth scientist, well, we do causal inference all the time. We can't do randomized trials for toxic chemicals and heavy metals and all that kind of stuff because it would be unethical. So we have to infer causation with these terrible pollutants. They had to do that with cigarettes, So causal inference is pretty common in epidemiology, isn't it?
Well, causal inference is what we are looking for, the causal relation. But I will say, well, I'm glad they know they need to distinguish causation and association. That's very fundamental for the statistical world. It's really hard to find the truth. It's a more philosophical question. But for epidemiologists, we tried our best to recover the causal association. And we do that by controlling for confounders. We do that by doing like randomized trials. When we can't do the randomized trials, we have observational studies and we have statistical methods. All the purpose is to recover the causation, the causal association, as good as we can.
In other words, with a high degree of confidence.
Yes, we also show how confident we are with those statistical tools. So that's what we are doing. That's why we exist.
Sometimes influencers repeat the industry talking point that epidemiology can only show associations, except in rare cases like smoking where the association is so strong. They often refer to the Bradford Hill criteria. Sir Bradford Hill was a very famous epidemiologist who gave a speech in 1965 outlining his viewpoints on what it may take to infer causality from observational data. The first was the strength of association. Smoking definitely has that. Some people have put a number on how strong the incidence should be to infer causality, and a common number thrown around is it should be about double the regular incidence. So they say this Harvard study only shows a 62% increase in the incidence of diabetes from the heaviest meat eaters to the lightest. And that's not strong enough to meet the Bradford Hill criteria. But I think we should hear what Bradford Hill actually said in his speech.
In thus putting emphasis upon the strength of an association, we must nevertheless look at the obverse of the coin. We must not be too ready to dismiss a cause and effect hypothesis merely on the grounds that the observed association appears to be slight. There are many occasions in medicine when this is in truth so.
I often think of epidemiology when I think of how the power of computing, big data, and statistics revolutionized internet search. I think Bradford Hill would be amazed at how far epidemiology has come since he gave his speech in 1965, using many of the same tools search engines use today. Some of you know I spent some decades working in Silicon Valley tech, and many of my friends worked at search engine companies. Google is famous for hiring PhD scientists who speak exactly like Xiao does, so cautiously. Many scientists rail against emphatic statements in science.
It is so antithetical to science to speak in such certainties.
But those statements are hard to resist on social media, even for scientists, because they do get clicks.
There's no reason whatsoever for humans to be attempting to get protein from plants. It is a fool's errand. They're wrong, Sherry. I'm right.
You calculated the risk of red meat consumption against different subsets of your cohorts. Males, females, people who exercised a lot, smokers, and so on. The one that surprised me the most was the people who exercised a lot. Can you talk about that?
Yeah, I think it's in our stratification analysis. The main purpose of that analysis is to identify if there's something called effect modifier, if the effect between red meat and type 2 diabetes differ by other factors. So for the physical activity, if there's really a difference between physically active people and those inactive people, I would say the stronger association we found in physically active people could be because, like, for those non-active people, there's there are more risk factors, and that can dilute the associations we are targeting on, like red meat. They have multiple factors, like unhealthy lifestyles, that can increase their risk of type 2 diabetes, and red meat is only one of them. But for those healthy people with higher physical activity, then red meat might be the only few that are associated with type 2 diabetes. That's why it's stronger.
So one of the shocking things that really stopped me in my tracks on this paper is how fish did. The title of the paper is about red meat, but fish played a prominent role in there because in 2 of your cohorts, it looked like the hazard ratio for fish was higher than red meat.
Well, actually, that also surprised us. So our results showed that substituting fish for total red meat and also for unprocessed red meat increased the risk of type 2 diabetes. But we think that might be due to how Americans eat fish, the cooking methods, the
deep fried, batter fried.
Deep fried, grilled, and that might the reason why it increased the risk. But we need more data to study that further. So it's kind of out of the scope of this paper. But I think, people will study that further.
Xiao referenced a paper about those cooking methods, and when I read it, this line jumped out at me. Red meat consumption, especially processed red meat, has been consistently associated with an increased risk of type 2 diabetes. For fish intake, although 2 meta-analyses of prospective studies consistently demonstrated no overall relationship with type 2 diabetes risk, opposing associations have been observed when separating the studies based on geographical region. A positive association, meaning more type 2 diabetes, in the US and Europe, but an inverse association in Asia and Australia. As an earth scientist, that makes me very suspicious of environmental contamination. I recently published an episode on PFAS forever chemicals. You can't eat freshwater fish, oysters, clams, lobsters, or crabs anymore in North America or Europe without very heavy exposure to them, and many publications link them to type 2 diabetes. Since Harvard's cohorts are North American, I guess we should have expected this association with fish. In a sign of the times, I'm seeing more data about contamination of eggs, too. And I noticed they didn't look too good in this Harvard study either.
You have a chart in your paper, figure 2, and it's got like 5 lines on it. It shows the response of higher and higher servings of red meat versus risk of diabetes. And it seems to be kind of mostly linear.
We want to explain why the previous studies, they find weaker associations than us, even before those measurement error correction.
I see.
Because they use baseline intake only, but we have cumulative average.
I see.
That's why the baseline only curve is much lower than the cumulative average curve, which is on the top.
I'm glad I asked you about that because I stared at that chart for a long time and I just didn't think I fully understood it, but your explanation is really good.
Well, you ask really a lot.
I did ask a
lot. I think, you read our paper so carefully, and you dig deep into that.
My philosophy has been for a very long time in science. I was a grad student at Stanford, and our professors taught us there aren't that many great papers in the world, landmark papers, ones that really matter. But those are the papers you really have to spend the time studying and filter out the rest. And I just thought, wow, this is a really important paper.